Welcome to the NSP Assurance and Analytics Update. My name is Yves Thibeault, and I'm a senior in NSP PLM. So today I'll give you an update on the assurance and analytics part of the NSP portfolio. On the assurance side, we'll focus on an update on network and service assurance, inventory management, and dashboards. On the analytics side, we'll focus on two brand new components that we have called Indicator Analytics and Baseline Analytics. Let's start with an update on the assurance part of the portfolio. First of all, I want to recap and review the high-level architecture. We've been evolving the assurance and analytics applications. We still are. Some of the key principles and points I'd like to underscore here, since these points will be repeated again during the presentation, is the fact that the applications that you see under mediation-agnostic GUI and OSS layer have been designed to basically take data from the network elements, whether they're managed via SNMP, gRPC, CLI, netconf, and basically receiving GNMI on change. And so basically making it transparent to the operators, people using the applications with the front-end GUI, as well as making it seamless to the OSS applications. Now, the power of this architecture also is once the customer has deployed this, you can also augment the deployment with SRs that are managed in model-driven mode, as well as add devices that are multi-vendor without having to touch the platform at all. And those devices would just become naturally managed under NSP. Now, let's take an example with fault management application. You see at the northbound here, the OSS interface has been unified. We have a Yang model that's defined with RESTconf APIs, Kafka notifications, nicely integrating into the OSS applications. And again, that's mediation agnostic, so whoever is using this at the top of the architecture doesn't need to worry about how these devices are collecting alarms in any ways, basically. Now, I'm going to focus a little bit more on the MDM side of the diagram. We have what we call MD adapters for alarms and fault management that can be augmented at any given time, meaning you can deploy new versions of these adapters, and they can support additional netconf notifications or GNMI on change and be mapped into the fault management application. Now, just a small note on the GNMI on change side of things. We also have a rule-based engine in NSP that allows us to program rules, additional rules, based on new GNMI events that are coming in dynamically without having to upgrade NSP. So now we're going to move on to the inventory management. We've added support of new models, Yang models, for physical inventory and logical inventory. Also adhering to the IETF hardware models and specific RFCs. The basic principle here is we're taking the RFC, mapping the objects and attributes according to the RFC. And for anything that's specific to the Nokia SR equipment, we're extending the RFCs. Similarly, on the logical inventory side of things with OSPF and ISIS routing instances or protocols and interfaces, we've based our models on open config models, and those get mounted under the network elements and get accessible through our RESTconf APIs. Again, so these two are mediation agnostic, so we can manage classic and MD device, and basically the interface to the OSS remains the same. A pointer has been provided at the bottom of the slide to give you a starting point to look at the new RESTconf APIs. Basically, you can get some examples, documentation, and it can get you started quickly. A quick sneak preview on the graphical user interface that's also coming based on the new inventory models for both physical and logical. I'm showing you here a starting point, which you may be familiar with within network supervision, called the equipment inventory view, which today captures the physical inventory. But in 21.11, we'll be adding also access to the operators for all the logical inventory. So again, OSPF and ISIS interfaces for both browsing or editing purposes. So you see here within the network supervision, we've launched the device administration in context of the objects. Could be a card, could be a port. And this is where the new tree is going to live going forward, is within the device administration application. There's an inventory tab that provides users with both a view on physical and logical, so the full set of inventory objects in the context of a network element. And then details can be looked at, browsed, and edited by the user within that application. Moving on to the real-time link utilization map within network supervision application. We've added the support for multi-vendor and SRs that are managed in MD mode. One interesting thing, if you've used that application in the past, is it hasn't changed very much other than the fact that we've extended the scope of what it can support network element-wise. Again, coming back on that theme that I was mentioning early on, mediation-agnostic, that's another good example here. And users will be able to launch the real-time link utilization map and monitor the link utilization, whether the devices are managed in classic mode or in model-driven mode. Now looking forward a little bit, also looking at adding support for the 7705s in the SR portfolio. This is in response to a lot of customer demands, but also showing you a breakdown per lag within the heat map as well. Another addition that we've done this year, so we used to have, and we still do, to have this within the fault management application, is a direct access to the network element for the operators in context of the task that they're doing. So in fault management, the starting point is an actual alarm. Now, with the addition that we've done in network supervision, the starting point is a network element, whether it's on the network map or within the matrix of NEs being monitored. And then the user can launch basically open a telnet or SSH session in the context of that node. You might notice a distinction between the two windows. The one in dark black looks like an emulator window, so that looks and feels like a command line interface, as if you were to launch it outside NSP. The one on the top right-hand corner is based on model-driven, and it looks and feels a bit different from a user viewpoint in the sense that you send commands and then the response will appear in the text box. Moving on to our service assurance application, service supervision enhancement summary for NSP 21. So one of the key additions is now being able to monitor services that are being provisioned through our brand new intent-based service fulfillment application. Obviously, we're continuing support of monitoring and management of services for the ones that have been provisioned via the former service fulfillment or the existing NFM-P as well. So no changes there. And we're also enabling OAM testing on demand in the context of nodes that are managed in model-driven mode. This can also be extended to multi-vendor nodes. And we'll take a deeper look at the OAM testing framework that's being made available this year. As you can see, again, a very similar context that I gave at the beginning, where the MD, the model-driven OAM framework, at the top provides a unified interface with RESTconf APIs, Kafka notifications for publishing OAM test results. We're storing, when you're collecting or scheduling OAM tests, we're storing those in various databases. Postgres is the default one, but we also have an option of auxiliary DB if you need more retention. And as you can see again, under the OAM framework, we have our SRs, our routers, being managed in classic mode on the left-hand side via NFM-P. The mapping files are the OAM mapping files that basically map between the NSP definitions and the actual SRs, the OAM tests on the SRs. And on the right-hand side, you're seeing the example of the SRs being managed in MD mode with a similar set of test types. a bit of a subset to what we have on the classic side, but quickly catching up to what we had. And you see also an extension to multi-vendor devices. So basically the framework can also extend to run tests on other vendors' equipment. Now we can take a look at this in action in the context of service supervision and the enhancements that are coming. You may be familiar with service supervision and being able to run OAM tests on demand today. So here the starting point is a group of services at the top level of service supervision, and then drilling in to a particular list of services contained within the group. The service gets picked and selected. And one difference that I want to underscore here is you see a list of endpoints. In the current version of the application, the user has to pick specific endpoints before being able to launch the OAM test. But going forward, you can actually launch the test here, as you can see, whether you've picked the endpoints or not. And then you're presented with a chance to pick the endpoints if you haven't done so yet, and then pick the test type to run the test. So going forward, this is going to be the unified way of doing this, whether it's for devices managed in MD mode again, or in classic mode. Pretty important introduction of dashboards this year. Early in March, 21.3 was the first time we introduced the health dashboard. Last year we had a few proof of concept versions, early versions, if you wish, of the dashboard. But now they've been made generally available, and they basically come installed with the network infrastructure management feature pack. What you get presented with here is at the top level is an overall health summary of your network, so network elements, services, and alarms. And we can just drill in a little bit into this. Now, the health summary is also provided in the context of a time period, so the user can actually pick whether they're looking at summary information in the last hour all the way up to like 24 hours. This is also used for trending purposes, so as user basically mouse over the different summary counts, the user gets presented with trending for that particular count. Within that dashboard, user gets presented with, again, network-wide network map, overall view of the network count, but in a graphical fashion, even using geomap. And on the map, user can select links or NEs and perform various actions like look at current alarms, plot statistics, on the links again, or NEs and ports. So the dashboard becomes kind of like your one-stop shop here for launching all the tools. Here's an example of the plotting on links. So just a quick recap at a glance, the user gets presented with network-wide alarm, equipment, and service health summary, along with different statistics on links and NEs, as well as an overall network map. And navigation is also provided in context, so as the user starts troubleshooting particular issues or resources that are affected, the user will be taken into existing assurance applications so that they can leverage existing tools that are available. Now, just an example on the service assurance side, looking at how the user can actually navigate and get to the tools that are available within service supervision. Here, we're zooming into the affected service summary, health summary count. The user can click on the affected summary count and basically gets navigated to a list of services that have different issues. You can see with the list of state causes some hints as of what may be affecting the services. The user can launch alarms from here or drill down right into the existing service supervision application in context of that service. The example we have here is the what I used to call the flight recording unit, so the event timeline, which here presents the user with everything that has been recorded related to the service and its components, endpoints, sites, bindings, and OAM test failures. So this is one of the tools that we get most positive feedback on, and again is available here from the new network count summary dashboard. Taking a look forward a little bit, adding an additional dashboard later on this year, this time in the context of troubleshooting purposes. So one of the starting point might be what I was just describing earlier on the network count summary dashboard. In navigating in context, the user would be taken into the new troubleshooting dashboard. Zooming in a particular resource, could be a network element, could be a port, could be a card, could be a service, could be a link. And the user gets presented with all kinds of details about that particular resource, all the state information, anything and everything that a user might need to get to the bottom of certain issues. You see a snapshot here of a new version of the event timeline that you may be aware of within Network and Service Supervision today. And we're looking at adding even more historical events into the timeline, taking into account the control plane aspect with IGP events and LSP events, as well as OAM test results. Just a quick note on customizations and personalization. The example on this slide here presents you with a way for the users to customize or personalize the dashboards that I previously presented, i.e. the network count summary dashboard and the troubleshooting dashboard. This is all in the context within the predefined dashboards that NSP ships with. The user can basically maneuver around, collapse some dashlets, move them around, and once the user is happy with the changes, can save them. Next time the user goes back into the health and troubleshooting dashboard, then they would be presented with the personalization that they've actually performed. Now, I don't have a concrete example of custom dashboards, but I do want to note so that you're aware, starting next year, you'll also be able to create your own custom dashboards, which involves maybe putting out the information that you'd like to see in a custom dashboard using predefined widgets and gadgets, saving those and sharing them with your colleagues as well. So that's worth noting. So that ends basically the summary and the updates of all the key enhancements and product advancements on the assurance side. Now moving on to the analytics updates. And starting with a review of the analytics portfolio here, you may be familiar with the NSP Analytics, which basically ships with prepackaged set of reports that are mediation agnostic, as well as ad hoc reporting capabilities, enabling you to create custom dashboards or reports within analytics. Now, you'll see in the next few slides, we'll focus on the two newcomers in analytics. One is called Baseline Analytics, which helps you here with more advanced sophisticated KPIs. So the user can basically configure certain key resources and have a baseline of statistics computed. And then the baseline analytics can then provide the user with detection of any abnormal or anomalies based on the baseline that's been computed. And we'll spend more time on this in the next slides. Indicator Analytics is another addition, enabling you again to provide more meaningful key performance indicators, starting with maybe simple metrics and creating your own and more sophisticated key performance indicators, along with thresholding and alarming as well. Now, the table here summarizes a number of things, starting with use cases. The existing NSP Analytics mostly focus with like inventory type use cases, capacity management, SLE reporting, which obviously is a key one, and trending. The two new additions to the portfolio are more focused on real-time monitoring and troubleshooting. And again, we'll spend more time on this in the next slides. The data sources just give you here an overview of all the data that the analytics use, mostly on the statistics side. So you see here different intervals and collection times, depending on which analytics product is being used, and the streaming is performed at a different interval. And you see here again on the theme of mediation agnostic, pretty much all the ways that are possible for collection of statistics via SNMP, CLI, gRPC, and so on are being used here, along as well as some event data is being captured and OAM test results being used. Now, the next row presents you with some transformation that the analytics product does to all that raw data being collected. The analytics one mostly focuses on aggregating the statistics and making them available in the context of creating reports, so for the report generation part. The baseline analytics is more focused on computing, taking all the stats that are being collected and computing baselines for key resources. And then that's enabling our training, our algorithm that's built in to determine if there's anomalies on the collected and computed stats. The indicator analytics will use the collected stats mostly to compute more advanced KPIs, key performance indicators, and also be used for generating of thresholds, alarms, and emails, and so on. Now, in terms of interfaces that users are presented with, the analytics application is probably well known by now that it has its own front end. The analytics reporting capabilities have also been embedded within the assurance applications as well, so that they're launched in context for the users. As for the two newcomers, they're mostly available within the Insight Administrator application as well as the Telemetry Viewer applications, and again, we'll take a deeper look in the coming slides. And northbound to the OSS applications, we have unified interfaces, so REST APIs, Yang models, REST-conf APIs, and notifications published on Kafka, enabling OSS applications to leverage that power and also potentially automate some of the actions here. So let's take a look at the indicator analytics, a closer look as an introduction. So an indicator is a measurable quantity of the quality and performance of resources in the network. It can be a simple metric, or it can be a result of a complex transformation here, that those more sophisticated indicators of network and service trends help you reflect and measure business goals that you may have. Rising and falling thresholds can be defined as well as with actions upon threshold violation. And as the events get published on the Kafka, as I mentioned, northbound, obviously you can also program your own automated corrective actions or troubleshooting actions. A deeper look here in the indicator analytics. So as I mentioned, so indicators can be simple or more complex. They get defined against a set of resources, could be like network elements, cards, ports. If they're more complex, a formula will be defined as well. And then threshold rules for rising or falling thresholds can be defined along with actions. So it could be an action could be an event, an email, or an alarm. And as part of the aggregate indicators, formulas like min, max, average, and sum can be defined, and all converging to generate a single key performance indicator. Here's a use case presented through some screenshots in our NSP applications, showing analytics working with assurance for demonstrating max throughput KPI on all ports on a given network element. I'm showing you here as a starting point, and we've seen it earlier, the real-time link utilization heat map as a starting point. It doesn't have to be the starting point. You can, as a user, also go there as a result of looking at some threshold alarms. So it could go either way or both ways. But here in this particular case, you see that some of the links may be hot on one of the NEs. Then you can launch the telemetry viewer to actually look at the details of some of the KPIs that have been programmed and computed through time. Here the user is given quite nice visibility, especially if there's been like a rising or falling thresholds on the timeline. And also if they've programmed alarms to be raised as a result of the thresholds being hit, then those would be visible within the fault management application as well as within the alarm list in network or service supervision. Now moving on to baseline analytics, which basically has two parts to it. The first part being focused on computing a baseline against key resources. So baseline analytics ships with a training algorithm that identifies the expected range of values for key resources of yours in your network with configurable degree of precision. Those statistics can be combined into more sophisticated indicators here of your network and service health. And you can define as many baselines here. The baseline analytics platform is quite scalable horizontally. Now the second part is more about detection of anomalies. So basically we'll flag based on all that historical data that's been captured, anomalous data patterns that normally would have been missed with the use of simple threshold crossing alarms defined on simple stats. Now, the anomaly events that get published on the Kafka bus can obviously be used here to automate either the corrective actions or troubleshooting actions. A few sample use cases amongst many that can be applicable here to the baseline analytics. Detection of silent failures. In some instances, there are network failures deemed as silent, where no alarms, no indications are necessarily provided to the operators. And here, the anomaly detection portion of the baseline analytics can really help in that respect and bring up visibility of those silent failures. Similarly, with dynamic lag expansion, instead of monitoring your lags only on simple utilization of the lags, based on the more on the baseline analytics that we have here, you can use more sophisticated indicators and determine when it makes sense to augment or increase your lags. Post-upgrade checks, something that obviously you want visibility of as you're going and updating or upgrading your network elements. So once your baseline analytics is programmed, this will continue on throughout. So during the network upgrade, the network element upgrade, as well as post-upgrade, and will flag any anomalies again. So as you can see, this can be pretty useful, something that usually operators are very concerned with. And last but not least, proactiveness on the SLA monitoring side of things, providing a faster response to your key customers and key stakeholders when indicators deviate from the typical patterns. We're going to take a look now at how you program the baselines. That's all done within the Insight Administrator. Basically, this will be applied to a set of key resources. So that's what the object filter is about. So it could be network elements, ports, and so on. The example here given is on interfaces. Then you have to be concerned here with the collection interval and the window duration, which here will help increase the accuracy during the baseline computation, but will not necessarily increase the storage. Then you get concern or focus on the telemetry type, so basically the type of statistics that you want to collect. So in this case, the example provided here shows you with transmitted and received packets for the interface telemetry type of statistics type. And detector here is the algorithm of choice that you will pick to help you with the actual anomaly detection and will help you with the range being computed on the baseline. Now, once the baselines have been computed and running for a while, anomalies may get detected and flagged. So we're taking a look here at some examples of looking at baselines after the fact. So going into the telemetry viewer to view those and basically selecting a baseline. The default view here is a stacked chart where you presented here with all the stats. As you mouse over and point your cursor to, everything will be timestamp aligned, so to ease the identification of root cause or issues, so simpler for you to correlate. So you see very visually appealing here. And you can drill down to particular baselines and get more details about particular, in a given timestamp, particular anomalies. And here there's an example of more details on the anatomy of the chart, presenting you with all the details, anomalies being flagged in red here for ease of reading. So time comes for a summary of the presentation on the assurance and analytics evolution. As you can see, I think you've heard me say this a few times now, we've evolved the applications to make them mediation agnostic, so enabling the operators and the OSS to manage their network in classic and MD mode seamlessly, and also extended to be vendor agnostic as well. All model-driven and with unified Yang and RESTconf APIs at the node bound. You've heard me talk to you about some of our new advanced baseline and indicator analytics, providing you with additional insights to your overall network and service performance. And you've also seen that these advanced analytics have been integrated within our assurance portfolio through threshold crossing alarms, anomaly events, and our network and troubleshooting dashboards. So just to end the presentation, some useful pointers where all the collateral is for NSP, and more specifically about assurance and analytics. You can find a lot more details about everything that I've talked to you about today. And I want to thank you for listening to me and taking the time to watch this video. Thank you.